Some 2,900 kilometers beneath us, at the boundary between the outer core and the mantle, there exists a very peculiar region. Unlike most of the planet, seismic waves slow down abnormally in this region. This indicates that the material here is highly unusual, distinct from its surroundings. Since its discovery in the 1980s, the true identity of this vast region has remained a mystery. Then, on November 1st, 2023, a study published in Nature suggested that this region may be a remnant of an ancient planet. It was a stunning suggestion. Deep beneath our feet, fragments of an ancient planet may lie buried within Earth. In the 1980s, while mapping Earth's interior with seismic waves, geologists found a highly unusual zone at the very base of the mantle. There, seismic waves, especially shear waves, traveled anomalously slowly compared with elsewhere. By analyzing the wave patterns, scientists concluded that the material contains more iron, is about 2 to 3% denser, and has a significantly different chemistry from that of the surrounding mantle. Studies indicate there are two such broad regions, one beneath West Africa and another beneath the Pacific. Sitting on the core mantle boundary about 2,900 kilometers down, they may be up to roughly 1,000 kilometers thick, and span areas comparable to entire continents. Scientists call them large low shear velocity provinces, or LLSVPs for short. Countless ideas have been proposed to explain how and why these regions ended up inside the mantle, but definitive evidence has remained elusive. In November 2023, Nature published a striking study. It argued that this vast, anomalous rock layer deep inside Earth may be a surviving fragment of Theia, the ancient planet that struck the proto-Earth about 4.5 billion years ago and led to the moon's formation. Over the years, many ideas have been proposed for the moon's origin. As evidence accumulated, most were ruled out, leaving the giant impact hypothesis as the leading explanation. In this scenario, Theia collides with the proto-Earth and the ejected debris eventually becomes the moon. Analyses of lunar rocks and soil returned by Apollo 11, commanded by Neil Armstrong in 1969, revealed compositions strikingly similar to Earth's. More recently, supercomputer simulations by NASA and Durham University have reproduced the Theia-Earth collision and showed the moon's formation remarkably well. Even with all this supporting evidence, one major question still remains. If some of the ejecta became the moon, where did the rest of it go? Scientists have scoured the solar system for leftover fragments of Theia and found none. That led some to wonder whether Theia ever existed at all, but perhaps we simply couldn't see it. Instead of floating above us like the moon, the rest of Theia may be buried beneath our feet, deep inside Earth. This is exactly the question that motivated the paper's lead author, Dr. Qian Yuan. Where is Theia now? If it's nowhere to be found in space, could it be somewhere we can't look? An ancient planet that seems to have vanished, and a mysterious continent-scale rock layer at the core mantle boundary. If those two turned out to be the same thing, it would clearly resolve all of these questions at once. The team simulated how the countless fragments produced by the Theia-Earth collision would move. Their results showed that the impact melts Earth's crust and upper mantle, allowing more than 10% of Theia's mantle to mix into it. Because Theia's mantle is thought to have been richer in iron, and therefore denser than Earth's, that mixed material would have sunk to the base of the mantle and pooled along the core mantle boundary. Over time, it slowly solidified and was reshaped by mantle convection into the two giant rock masses we see today. According to the study, Theia's mantle would have been about 2 to 3.5% denser than Earth's, which agrees well with earlier geophysical estimates and makes the scenario more convincing. On top of that, a recent volcanic eruption in Iceland produced material with a composition and formation age distinct from normal mantle. All of this strengthens the idea that what we're seeing inside Earth may indeed be the remains of Theia. Of course, even with these results, this is still a hypothesis. To truly test this hypothesis, we'll need to analyze rock samples from deep inside the moon, not just from its surface as we do now. That opportunity is expected to come with NASA's Artemis program, a crewed lunar exploration program targeting 2026. 4.5 billion years ago, the young Earth was a place where life could not survive. Then, one giant impact changed everything. Earth's spin axis tilted, giving rise to seasons. Extra iron was added, powering a strong magnetic field. A moon was born, and with it the rise and fall of the tides. As a result, Earth was able to become a world of life. Is this story just a hypothesis, or is it really true? The day to verify it is getting closer.